Okay, so for today's session, we will have these topics: logistic network planning, which means that how we are going to plan our network. So we discuss about that you can have number of warehouses. We discuss about the road transport, the kind of product you have, but at the end of the day, we need to understand that how this planning of logistics will happen. What is the best way to move product from one place to another place? Information sharing, it's a big topic as of now, and you will face in your if you work into logistic company, if you start working with supply chain management, you will find that information sharing is a big concern even in today's IT world. And therefore the bullwhip effect, we will again revisit it. Supply chain performance management, which says that how you can manage and measure the performance of your supply chain, which means that if I have a supply chain, whether it is good or bad, I need to have some parameters to judge it and to ensure that I am not doing an over engineering or under engineering for my supply chain management processes. Right after that, I believe there will be a online submission of the assignment, which is nothing but more of a multi-choice questions. I'm not sure when it has been scheduled, either maybe today or tomorrow. But yes, there will be a multiple choice questions over there. Some questions will have more than one correct answer. Some questions will have only one answers which are correct. And please do read the questions very carefully. Whatever we have discussed in last session and whatever we will discuss today, this quiz will compromise of those topics altogether. You really don't have to run from pillar to post if you are listening to these sessions and if you are going through the slide decks. Okay. um, the first topic, the logistics network. The logistics network consists of facilities. So we talked about the vendors, we do talk about the manufacturing centers, we talk about the warehouse, the distribution centers, and definitely the customer. Now, the customer and vendor, they keep changing from one place to another place. So I can be a vendor and at the same time I can be a customer. So if you talk about the chain, at each link of the chain, there will be a vendor and there will be a customer towards the end. And in the entire chain, the very first person will be the vendor and the very last person will be the customer in all. And then raw materials and finished products that flow between the facilities. So these are the things which compromise of a logistic network. And when we say that we have to design a logistic network, we need to design how efficient I can place these things in my supply chain network to gain maximum benefits at the minimum cost over the period of time. Now, if I look from the network design perspective, there are some fundamental issues. And the biggest issue is the warehouse. Because I can have a plant, right? But then this plant will manufacture a lot of things and it has to stuff my finished product at my end to a warehouse from where the deliveries will happen. So the question is how many warehouses I need, right? Why it is important? More the warehouses I have, the more the inventory I have to maintain, right? So if I have 20 warehouses, I need to maintain inventories at 20 places. And we discussed in last session that having inventory and optimal inventory is the biggest challenge in supply chain management, because running with inventories create cost and it also create risk. Location of each warehouse. So again, what is the location of my warehouse? How easily it is accessible for my transport system, as well as what are the things which are required for my warehouse? For example, if I am having a cold storage, the power supply is very important. So from that perspective, we also need to figure out the location of each warehouse. Whether it is at outskirts, fine, it is at outskirts because it is cheap. But do I have roads over there? Do I have a provision of having a rail track over there? So those locations are also a problem. Size of each warehouse. How big should be my warehouse? It should be just 500 square feet, or it should be 5,000 square feet, or it should be 500,000 square feet of warehouse. It should be multi-storied, single layered, what kind of a product I am saying. So what is the size of my warehouse, and then allocation of products to different warehouses. So last time we discussed also that you have multiple types of products which are coming out of from a organization. For example, Unilever, so they have a different variety of products. The question is that which product goes to which warehouse based on the demand, right? So for example, in Delhi NCR region where we guys are living, there might be a specific requirement of specific brand, a specific container size. Maybe in a smaller city, right, which the typical, the economic guru said, tier B or tier C cities, the demand is very different, the packaging required is very different altogether. So what product goes to which warehouse is another problem. And allocation of customer to each warehouse, we also discuss about the segmentation of the customers, right? We discussed in last session that we have to have way to segment our customers, right, based on their behavior, based on their needs, on their various parameters. We need to segment our customers, and then we have to assign those customers to those warehouses over there, so that I know this warehouse caters to these kind of customers. Now these things all are interrelated, and as well as they have a lot of inputs coming from the social perspective, from the economic perspective, right? For example, today if I talk from the IT industry perspective, Gurgaon is a big brand, Faridabad is not, Noida is not able to go forward with the IT part. If I go to Bangalore, it's all IT. Chennai, it's progress, it's stopped. Mohali, progress and stopped. So again, all these things are not like ITs are not there. You cannot, you have Wipros and Infosys of the world in all these cities, but they are not able to grow because it's not about Infosys or Wipro. It's a lot of things which factors over there. One of the factor is the language, one of the factor is the environment, the kind of weather they have in Chennai. So all those things also contribute to your growth, right? For that location itself. So when we say network design, a lot of things need to be thought about it. Now, when we say we have the issues, the fundamental question is that okay, I have these challenges. I need to design my network, but what is my objective to design my network? So my objective is to balance a service level, right? So we all agreed last session that we have a service level. For example, Amazon says I will give you a same day delivery, or somebody else will say I will give you a delivery in 7 days. So that's a service level. Now my objective is that I should be able to balance my supply chain against the service level. There is no point of having a super fast delivery when I know I can deliver in 7 days. At the same time, I will lose my customer if I promise for a day and I take 7 days to deliver a product. So which means the balance service level against production and purchasing cost, right? So with every location, the production, the time, the money you spend to get the stuff out is variable, right? So for example, if you have to have an industry, if you have a easy access to the water, the cost is lower. But if you have to have a you have to import the water, then it's a very costly stuff over there. Inventory carrying cost, right? So what kind of product we have, where are my warehouses, how fast I should deliver, is my product innovative or it's more of a functional product? In those cases, the inventory carrying cost also varies and contributes to my network design. And also the service level I have promised. Facilities cost, right? Storage, handling, fixed cost, right? So when we say storage, for example, you have a cold storage, what is the operational cost to it? Handling of you have people, have forklifts and moving all those things from truck. For example, few trucks will take extra money to go to the warehouse because of poor roads, or it takes longer time to reach to a typical warehouse. At times, for example, you have to do a shipment via sea, but all the way from your warehouse to Bombay Nava Shiva seaport, you need to pay a huge amount of tariff by moving that via road itself. So all those things also factor in your network design to safeguard your service level. And the fixed cost, which is like, that's my cost. I have to pay this kind of a money, your investment in the warehouse, in the properties. All those things are like typically fixed costs. And most important, which we have just talked, is the transportation cost. What is the amount a truck or a sea shipment or a rail carrier or an air shipment will take to manage my service levels within that network diagram, all the way from my warehouse to the person who is intended customer of that product. So we would like to find a minimal annual cost configuration, right? So we will talk about a horizon of a year long, which means that sometimes you have to make a investment today, let's say for quarter one, and it seems that quarter one is not giving you profit, but the investment which you do in quarter one will give you efficiencies in quarter three, quarter four, which means that by the end of the year the overall business is quite profitable. So at times you have to invest from that perspective also. So minimal annual cost configuration of the distribution network that satisfies product demands at specified customer service levels. Always understand there is no thumb rule for network design saying that if you do this, your network looks good. These are some guidelines, these are formulas, mathematical models, but they all need to converge at one point, that how happy your customer is. Retaining customer is a big deal. So if you are able to retain your customer, that is more important than anything else, because that's a repeat business you are going to get, and that's where your service level are agreed. I believe that you all have seen certain contracts where service level agreements are very clearly stated. So they actually say that, I assume that this will be reaching 7 days. Within 7 days, if not, then you start paying me damages over there. The product should be in good quantity, otherwise I will again ask you for the money. And at the same time, there are payment conditions saying that you have to pay in 7 days, otherwise I will charge you 18% of interest. So all those legal complexities are in those contracts to build, to define a service level agreement. So these all are service level agreement at a different stage of services and what kind of services somebody is going to provide. Let's go to the next. So we talked about the challenges, we talk about what is required for network design, why we need it. But the question is that if it is a mathematical model, if we really want to design, and if you know my warehouses, but I still need to know what exactly is all required to interlace this. That is the data we are talking about. So first of all, selection of products is required per warehouse, which means that you need to know all your products. Then we also talk about the challenge, which warehouse to which customer segmentation. So you need to identify your customers, your stocking points and sources to it. Then we also talked about that, if I am doing a segmentation, if I am doing a warehouse and I need to know which product goes where, which means that we are talking about demand. So I need to know the demand of each product based on a customer location. Now when I talk about customer location, it is not about an individual entity. It's not about person A or person B, it's about the segmentation. So I know there's a typical set of customers for which this is my demand. Transportation rates, very important aspect. In India, transportation is a very expensive stuff. It's a very expensive thing, and most of the money which today's logistic companies are billing, and where the operational efficiencies we are trying to gain, and which is the biggest concern today, is the transportation rate. It is very unfortunate that we have big rivers in this country, but we do not have waterways available for us. It is very cheap over there, and most of the countries waterways are used very efficiently. Even the railroads are used very efficiently. We don't have that efficiency in our networks. That's a very unfortunate situation. Warehousing cost. So you might have seen newspapers where they say that Food Corporation of India is not able to store food because they do not have cold storages, they do not have warehouses to stuff that food. So if you have a record production of wheat or barley or corn, right, we do not have places to stuff them, and that's where they start rotting at open places. And that's where we say that warehousing is a very important, and there is a cost to that warehousing. Setting up a warehouse, it's a very costly thing. Shipment sizes by product, right? So again, um, what is the stock keeping units? I am talking about pallets, or I am talking about individual small boxes, right? So what may happen that I will send you a pallet, but then as a further division, the pallets are broken into individual products over there. Order patterns by frequency, size, season, content, so which is basically one of a typical component of a demand forecast. Is my demand seasonal, right? For example, in when the once a winter comes, all of a sudden you will find that retail shops are full of moisturizers all the way. Cold creams are available, right? In summers, it's all about sunscreens which are there. Cotton clothes are there in summers, right? Shorts are available in summers, but in winters it's more of a lowers and track pants. All those things are there. So all these products, from the season, they vary. Size, right? It's very important. For example, if you go to a place where most of the population is very cylindrical in shape and shorter in size, you will not be able to find clothes of people who are, let's say, 6 feet or 6 feet tall altogether. In India, even if you are a 6 feet giant, from the Indian perspective, 6 feet is typical giant over there, right? Amitabh Bachchan is 6'2", and everybody is still gung about the height factor over there. So 6 feet is like taller stuff, which means what? That if you go to a shop and if you ask that I want to wear a shoe with a size number 10, difficult to find. Most of the time you will find 7 number, 8 number easily, but finding number 10 or 11 is difficult because there is not much of a frequency over there. Order processing cost, you need to know what is my cost of processing an order. So if I process, and this will impact your logistics part of it, right? So if I have a half load of a truck going, I'm wasting half of my capacity of the truck, right? So what is the cost of processing an order? What should I do? A collective processing of order? Should I do one order at a time? That is important. And the customer service goal, what is my goal in terms of customer satisfaction? We talked about the cost and we talked about the value. Value is a perception, right? So you simply cannot ask somebody to pay you 100 rupees because you think it's a value. You should be able to give that perception to the customer that if I am charging you 100, right, and this is costly thing, because for most of the market that product is available for 75 rupees, it is very clear that for that 25 rupees customer wants to you want customer to pay, there need to be a different level of value which comes with customer service. Extended warranties, items will not be sold which are broken. You will receive everything intact at your place. Good quality. So those things goes for the customer service goals. And whatever your industry, with every industry, the customer service goals keep changing, but the rule of thumb is that happy customer means good business. So this is the other 9 things which we need to design our network. I think I have some problem with the network. Give me a second. I hope the slide is still available and you guys can see it. Can you type yes? No. Good. Thank you. Thank you, Manpreet. So we talked about a lot about customer as well as segmentation of it. So, and we say that based on customer locations or type of customer we have. So one technique which we need to use in our data network or designing our supply chain network is aggregating customers. And you should all look into this very carefully because you will face this as your first challenge when you go into supply chain management, because this is the first thing which they will ask. A happy customer, different level of customers, different types of customer, all almost having the same kind of a service. So you have to aggregate customers, right? So when we say aggregate customers, we talk about customers located in close proximity are aggregated using a grid network or clustering technique. So I will say in my Delhi NCR, right? So let's say Gurgaon is pretty big, right? From the aspect that there are a lot of companies over there, but perhaps the golf course road is something where I have maximum customers, and after that, the another pocket which I have is towards Manesar. Now I really do not need to set up something in sector 14 Gurgaon, which is like typically old Gurgaon, because I don't have customers over there. So based on the proximity, right? Or the we try to aggregate customers, and we say, okay, this is a group of customers, aggregation of customers is required. And this is this cell which we're talking about, the place where all these customers are there, right? We call it as a customer zone. Now you will figure it out that there lately there used to be there's a concept of transport nagar in every city, right, where all the trucks and all the logistic company used to be there. Now we still have that transport nagar in place, but most of the logistics companies are having their offices which are very near to their customer level altogether, right? For example, if there is a company A and he has a typical cluster of cluster in Connaught Place, so they will rent a small office out of Connaught Place, and their management will sit out of there so that they can manage the customer from there itself. And they can, so that's customer really don't want to see the truck, right? But he wants someone to be approachable, right at any point in time. So that's where that clustering happens, that will help you to relocate yourself, right? Or perhaps if you know where this cluster, if you are going for a customer visit, you can perhaps cover a couple of customers all the way. Very important aspect for defining the right set of customers and aggregating them. What is the impact? So the impact is, as we discussed, the customer zone balances loss of accuracy due to over aggregation, right? So over aggregation means what? Sector 16 is one aggregation, sector 25 is another aggregation, sector 28 is another aggregation, right? So within the city, every sector I am trying to aggregate. Okay, I have three customers, I will aggregate at three level. No. So this customer zone where you collect a lot of other things, that becomes your aggregations. Whatever the loss you are making, that helps you. And needless complexity, right? So for every 16, 20, every other sector, every other area, Tilak Nagar, then next to it, then next to it, that that happens with aggregation of the customer, but customers don't balances out. And what affects the efficiency of the aggregation, right? So number of aggregated point, right? There is a number of different zones we are talking about, and the distribution of customers in each zone, so that actually affects the efficiency of the aggregation. Now I will ask the class to tell me what is the difference between the effectiveness and the efficiency. Just give a try. These are dictionary words, but they're very important to understand. You can type in the chat window what is efficiency and what is effectiveness. Manpreet, I am at slide 7 right now. I'm not sure if this is the problem at your end or not. Is everybody seeing slide 7 or they are seeing slide 1? Nazmuddin, I will answer your question. What is shipment size? Okay, thanks, Manpreet. So, shipment size is basically defined at what is the size of shipment you want to send in the most cost effective manner. So it varies. It varies from contract to contract, from order to order. So I can say what is my shipment size. I will say it is like, say, one container of so and so dimension. So that is the size of my shipment, or a pallet, right? Or a box of, let's say, 2 by 2. So shipment size varies over there. So shipment size is that what I am going to ship is the shipment size. It's not, and it at times it is just a dimension of a container. At times it is also about the individual units. So if you have seen some shipping containers going, they will say, okay, this is my container, and at times that container also signifies that, in this shipment I am sending you 400 stock keeping units of a typical product. Now the same shipment or the same container can have another 1,000 units of another product. Uh, Based on the sizing and what can be stuffed into that container itself. So it really depends at what level you are looking at the shipment, and shipment size always vary. There is no one single shipment size which fits all. That, did I answer your question? Manpreet, efficiency is to do tasks with best possible output with given set of input. Effectively doing something is to get best output. Good, good. That's good. Manpreet, you are almost there. So understand these things, that efficiency doesn't mean that you will be effective. Efficiency means that I am giving you, $100 or 100 rupees. What I am getting out, 110 or $100 altogether. Effectiveness is that, okay, I am giving you $100 and you are giving me a gold coin out of it. That's effective pass out of it. It's a very different analogy to understand it, but yeah, very two different terms, and you should never use them interchangeably when you are under discussion about supply chain management. It can be efficient, it may not be effective, right? And it may be very effective, may not be efficient altogether. So why aggregate? Because the cost of obtaining and processing data, right? So if I'm doing aggregation, that helps me in terms of managing the cost of obtaining and processing the data. I cannot do that for individually, I can do it at some level altogether. The form in which data is available, right? So this is also very important, right? For example, is, and this is more applicable when we are talking about from even a broader aggregation, right? From state to state, or perhaps country to country, or technology to technology, and the size of the resulting location model, right? So if I am taking a big location, right, it's difficult to manage it. One of the analogies is that, if you have a very big state, it's difficult to manage a big state, so you keep dividing them, right? We got Uttarakhand, we get Jharkhand, right? So all those things happen because a big state is difficult to manage. You cut it to manage it out of it. So kind of aggregation, but yes, it's important. And the accuracy of forecast demand. So you need to understand that, requirements which are applicable to a particular area may not be applicable to another area. So aggregation is very important, and that's why you need to understand that what aggregations mean. It cannot be individual customer, it cannot be two or three people. You need to take a very collective approach and define, okay, I will aggregate at this level. Now if that aggregation works for you, it works for you. It may happen that you have to either roll it up or you have to roll it down based on the results which you are getting over there. For example, you take two small aggregations and you are finding that the data which are for both these aggregations are almost similar. Is better to club and make it one. Or it may happen that you are having, one aggregation point, and you are finding that you are not able to find any pattern out of it. So you have to break it to figure it out. Okay, now whether I have a pattern or not. So these things happen, and this comes with experience. But yes, always keep an eye on those aspects. So let's talk about a demand forecast, right? So we talked about bullwhip, a very small thing on bullwhip effect. So we will discuss what is demand forecast. So demand forecast, three principles of forecasting, right? Forecasting is really correct, rarely correct, because it's a forecast, right? ये अंदाजा होता है, right? It's just like a guesswork based on some data, and you say, okay, based on what happens in the past, I assume that this will happen, right? So forecasting is rarely correct. You will always have a deviation to it. The question is that how less you can achieve in terms of deviation, but there will always a deviation. Longer the forecast horizon, the worse is the forecast. If you try to predict for next 50 years, your forecast is definitely extremely poor. But if you try to forecast for a week, for a month, you have better results, because those week or those month will translate into the next month data. So always try to do forecast for a smaller horizon, right? So if you look at a lot of financial data, there is a quarterly forecast, and then there is a annual forecast, and with every quarter result, they keep adjusting their annual forecast, right, in terms of what we are going to achieve in terms of profits at the year end. The reason is, for the quarterly input, the performance in one quarter is feed into the other quarters, and then you again fine tune it. Aggregate forecasts are more accurate. Now this, try to understand, if I have, it's basically averaging out, right? So the more the averages I have, I will be more closer to the overall situation, right? So aggregate forecast, so if I have forecast for one place, then another place, then another place, try to aggregate those forecasts to build one comma. So one location will say, okay, I have a demand of 100, other will say I have a demand of 20, somebody will say I have a negative demand of minus 20. If you aggregate these forecasts, you will figure it out that the overall requirement for you is about 80. You may not need to produce more than 80, because forecasting is balancing you out. Now, recommended approach, typically try to use 200 to 300 aggregate points, and friends, try to understand, this is not something you can do manually. It needs to be done with the help of softwares, uh, it, from the help of Microsoft Excel. These will help from their respect. If you try to do it manually, it is a mammoth task. You can't do it. You can do it, but it will take itself a project altogether. So at least 200 to 300 aggregate points. Make sure each zone has an equal amount of total demand, right? And place the aggregate points at the center of the zone, right? So if you do this kind of a typical exercise, if you try to simulate this as the current trends, generally the error is around 1%, right? Plus 1% or minus 1%, which is actually a very good, I will say it's a very good forecast. Now again, this will not happen on day one. So when I say from 200 to 300, you need to figure it out what are the best aggregate points for you, right? Have you done the aggregation correctly? So individually you have to do this, and then you have to do it for all the locations, and then you so there are a lot of softwares which are available as a freeware on the market, which helps you to define these demand forecasts at a very basic level. And if you go for a pro version of these softwares, then definitely they are very strong mathematical models working behind it. But yes, software is required for these things. You can also do it manually, if you want to. Then we have a concept of product grouping, right? So last session we discussed different type of products over there, right? Something very innovative products, functional products. Then a company like Procter and Gamble, right? Unilever, they have a huge number of product list, right? Even if you talk about the car manufacturers, with an exception of one or two, they have huge number of variants over there. So product grouping is very important. So companies may have hundred to thousands of individual items in their production line, and variation in product model and style, right? And same products are packaged in many sizes, right? So if you are going for an offer, buy one get one, or you have this kind of a packaging, then you have variation in the packaging altogether, different sizes. You get a 100 ml bottle, you get a 1000 ml bottle, right? You get 250 ml bottle, right? So all those things has, and these all are different kind of products, right? So somewhere, where people are, for example, if you go to western countries, everything is being big bottle size, right? So they buy a big bottle of shampoo. Here we will find small bottle of shampoo over there, right? When the big bottle of shampoos are used by the saloons altogether. So different customers, different areas, a lot of other things comes in, and you have different sizes. For example, even the shampoo comes in a 1 rupee sachet altogether. I don't know whether it still comes, but yes, it used to come in those 1 rupee sachet altogether, which is like people who are seldom use those kind of sachets, or people who are traveling a lot, they use those kind of a 1 rupee sachets over there. Collecting all data and analyzing it is impractical for so many product groups. So understand this: you simply cannot analyze every other product, right? If I say, okay, I will have a demand forecast for 100 ml, then I will have a demand forecast 250 ml, then 550 ml, and then for variations of it, dry skin. So you have to group these products to figure it out that what exactly is required. And that's where the beauty is, that information technology helps you a lot with this. If you are looking from the transport perspective, let's say you are having a fleet of 100 trucks, it's a very different ball game then, right? So you have to see, okay, which kind of trucks I have to send which way. For example, where if I am going to a area which is raining, then I have to have a covered truck, or if it is just like something which I can open, or I can just put a canopy on top of it, I should work with this. So it really depends that you have, are you able to group it? But yes, it's at times it is very time consuming, and it becomes impractical if you start doing for every other location, every other product, every other configuration. It simply doesn't work out. In practice, items are aggregated into a reasonable number of product group based on distribution pattern, right? So when I say group the products, these are the four things which you should consider in grouping your products. Distribution pattern, what kind of products we are talking about, right? So you can talk about apples, right? But and you have variety of apples over there, but you cannot have apple with oranges, because they are different product types. Now somebody can say they are fruits, fair enough, but that's at a very high level, right? Shipment size, right? So I believe somebody asked me the question altogether, right? So what is a shipment size? So there is no defined shipment size. You all need to understand that shipment size can be anything. You need to figure it out from your forecast, what kind of shipment I am sending, right? Can I club it with someone else or not? And what is the most appropriate shipment size? For example, my demand is, let's say, every retailer is asking, let's say 20 bottles, right? And I say, no, my shipment size has to be 50, right? Then nobody is going to buy with you. They will say, boss, what will I do for what those another 30 bottles? I don't have a forecast for this. So shipment size is also very important. And transport class of merchandise, very important. What kind of transport we are talking about here? Road, railways, waterways, air, and then in that also, perishable, non-perishable, fast, slow. So all those things, comes over here. It is common to use no more than 20 product groups. So generally, the idea is, in general, so let's not talk about the big giants in the world like Unilever, all those things. In gen practice, most of the organizations try to group their products within 20 over there. I've been part of larger implementations where this typical product group has been breached. But yes, they are companies which runs into multi-million dollars of business. So they are, and they can use extremely heavy softwares which can analyze this. But still, we always recommend that the product type is should not be unreasonably huge. 20, 25, 30, fair enough. Beyond that is difficult. And even in the current scenario, when the talks is on the specialization, the grouping is again further drill down to 10 or 15 altogether, may not be even 20. Okay, so we talk about a couple of things, and I'm always saying that transport is a big thing. Why transport is a big thing? Because that's where the money burns, right? You have a warehouse, from warehouse to another warehouse to another location. You are burning fuel, and fuel is an expensive thing, right? So every time you have a hike in fuel prices, you hike the cost of the product, because that's where the money is burning. So trans to to manage what rate I should charge effectively to ensure a efficient supply chain management. Now, for example, if I'm talking about Ola, Uber, they have a very flat charge, right? So many rupees per kilometer after 6 p.m. you have. So they have also different types of rates, right? So one rate is like from morning 8 o'clock to night 8 o'clock. From 8 to 12 you have another rate. From 12 to morning 8 o'clock you have another rate over there. So different types of rates. So huge number of rates representing all combination of product flow. One thing. An important characteristic of a class of rates: truck, rail, you know, postal services, trucking companies, right? Now, generally, if I talk about these kind of a transport thing, they are very linear, right? It is 5 kilometers, I will charge this, right? It's 1,000 kilometers, you have a per kilometer rate. Just implement, multiply this. I have a rate, and then the number of days and my driver day allowances. So they are pretty much linear. Find this, but you can always have an efficiency over there. So, why it is important to understand that rate estimations? Because we have this concept of LTL, right? LTL is nothing; it is less than truckload freight rates, right? So what happens is that, what is LTL? Let's say my truck is capable of carrying 1,000 liters of oil, right? I have a big truck. I can carry 1,000 liters of oil. But if my load is 500 liters of oil, how should I charge? Because whether I take 500 liters or 1,000 liters, I will practically burn that much amount of fuel on transporting it. But if I start charging from that perspective, I am losing money. At the same time, the customer will say, since I am not using your 1,000-liter truck, it is your problem to provide me with a 500-liter truck. Why should I pay for another 500 liters, which I'm not even consuming? So, less than truckloads are the major problem across the globe in terms of determining the freight rates. So, how we manage this thing, right? So, what happens is that, with less than truckload freight rates, there's a typical technique where we define uh, a shipment class, right? It's just a class saying, okay, whether it is 50% or 60% or 80% or 20%. So whatever is left, so based on that, we do from 500 to 50. That is how we define the classes over there. And higher the class, greater relative charge for transporting the commodity, right? So if I'm saying, okay, it's a 500 LTL, I will say, okay, man, I need to charge you more, because I know I cannot ship anything with that truck altogether. So you have to pay me more, right? It becomes a bit expensive over there. And the number of factors are involved in determining a product specific class, right? So how to define this class? Density, right? How dense is the product? For example, transportation of hay, right? So it is very light in weight, as long as it is not, sprinkled with water. It is a very light stuff over there. So density is not much. Talk about mercury, it's very dense, right? Talk about iron, or not iron rods, iron sheets, dense, right? Ease or difficulty of handling, very important aspect, right? Highly inflammable, right? Oil, gas, nitrogen oxide, cylinders. That handling is difficult, right? You simply cannot, in and out of the truck over there. The same time, taking sand, stone, household movements, pallets of washing powders, all those things that comes into the transport area. So they are easy to handle over there. So that also defines what class it belongs to. And the liability for damage, right? Now, damage at both ends. What if the products get damaged? For example, you are taking glassware. There is a high chance that your glassware get be broken given the conditions of the road or the way driver is maneuvering the truck, right? Or the way the handlers are putting the pallets on the truck itself. Who is liable for the damage? The one who is transporting, one who is not transporting, paid by insurance, then who is going to pay the premium of the insurance? Who is liable for the damage? At the same time, if you are taking very hazardous material on your shipment, right? Sea shipment or like oil, right? So what if the oil leaks, right? Last year, 2 years back, British Petroleum has a big leakage in the sea with its oil. Who is responsible for that? Who is going to pay for damages? That's a big question, right? At the same time, somebody is taking just some household stuff, right? So liability of them is covered by insurance, but again, at the end of the day, just a household good. We don't expect a too much of damage over there because just individual damage. Or at times you are taking few products which are like say nuclear warheads or things which are full of radiations. So there the person, even as a driver also, there is a liability, right? So liability that his health will be damaged, so you will charge an extra premium over there. I think somebody's. Can you all be on mute? Okay, I muted it. Fair enough. Nazmuddin, you have a question. Let me see what question you are asking. Owner of shipment, not always. Not always. If I am reading a question, not always the owner of shipment. That is not the case. It really depends. It depends when the stock is moving with you. I can give you an example for oil and gas industry where I have worked a lot, and transportation is a big deal. So if I am moving my truck from one plant to another plant, it is not necessary all the time that the time the truck leaves, the ownership lies with the receiver. No, at times the ownership lies with the person who has shipped the oil until it reaches at the port. At times, the ownership of the truck is right at the point when it starts moving from the person who is selling it. So it depends on the contractual aspect to it. So just do not take a thumb of rule. Maybe in your business, in your scenario, that might be a case, but in practice, it is not always the case. So, Nazmuddin, is this your query, or you have something else to say? Okay, I hope I have answered your query. Something says owner of shipment. Something says. Didn't get you, Nazmuddin. I think you can type your question elaborately, or you can discuss this offline also. Okay. So this is so where it is less than okay. So one we had talked about the LTL. Then there is a basic freight rates, right? So with the commodity class, commodity is like wheat, barley, iron, ore, minerals, oil and gas, right? So all these are like commodity. They are traded as a commodity over there, and the source and the destination zip codes, right? the specific rates per unit weight can be located, right? So I will say I have a weight, I have a rate, and within this zip code, this is my rate. Multiply this, you will get a straight something, right? So if you are trying to send me, 1,000 kg of something, so I will charge 1 kg per rupee. 1,000 kg, I will charge you 1,000 rupees for so and so postal code, right? Now, this SAR, CZAR, it's complete zip auditing and rating system. This is a typical US engine. India doesn't have this kind of a thing, but in US you have this um, way of identifying the basic freight rates is used over there. And finally, to determine the cost of moving commodity A from city B to city C, use the equation weight. So what is the weight and what is the rate? So just multiply it, straight formula. That's a very basic freight rate, very linear movement. It doesn't change all the way. So if you talk about the LTL, which we are seeing over here, right? Sorry. You'll find that these are the charges and these are the distance from Chicago. Now, do excuse me with this, US term, because the books which I am referring to, they all are written by US authors, because that's where the most of the research is happening as of now, and they cite those example, and they are using IT, so they also have a good amount of data available with them. But just interpret it from that perspective, right? So these are the, if I have to go from one place to another place for a shipping of 400 lb, which is actually pounds. I never able to figure out why pounds is written as lb, but there it's 4,000 pounds. And this is my charges, and this is my distance from Chicago, 141 miles, 384 miles, 454 miles, so on and so forth. Now if this is class 100 commodity, look at the price. This price is moving over here, then it goes up, down, and then it becomes pretty much. But it's class 50, so higher the class, higher the charges. So class 150 of commodity is having same pattern, but the charges are high over here. So you need to define the correct class of that product, of that commodity, and then you can drive the charges over there for LTL. Now, one of the other issues which happens with all these techniques is the mileage estimation, right? How much kilometers in a liter of an oil my transport moves? Now, it is applicable to your ship, it is applicable to your air, it is applicable to your road transports also, as well as the rail transports, right? So, street network, what kind of network visibility I have, how good are the streets, and entry times, no entry times, all those things are over there. And straight line distances. Now, generally, when we say the mileage part, it has actually been determined that what if I am running, with a liter of an oil in a straight line without any stoppage, no speed breakers, the roads are absolutely good, the tires are good, the air pressure is adequate, so everything is perfection. That's how the mileage comes in, right? But generally our traveling across the world is not in straight line. It's always have corners, turns, roundabouts, humps. We have to climb roads, we have to be downhill, uphill, so all those things also caters to the exact mileage or the typical mileage we talk about. So what is the mileage of my truck? And it also depend on the kind of load I am taking out, right? So heavy load, slow down the speed. Dangerous material, again, slow down the speed. So all the things are also considered over there. Now, this is a typical straight line, application, right? So we want to, if I have 2 points A and B, and I have longitude and latitudes available between those points, right? Then it's a simple geometry, right? So the length of that line is basically 69 square root of longitude of A minus longitude of B square plus latitude of A minus latitude of square and square root of it. Pretty much standard formula to determine the length of a line between x1. So if you have gone through those your 10 plus 2 areas, you have this geometry where it says, okay, I have a line at x1 x1 y1, I have another line at x2 y2, find the length of. So you determine those by this formula itself. So you will get a distance over there, right? And again, it is a straight line, very accurate, absolute accurate if it is very short distance. But in all practical reasons, my distance is never straight, right? My distance is never straight. So this is a formula which is used globally to find the distance between point A and point B. Twice of 69, inverse of sine, square root of sine latitude minus latitude B, divided by 2 square plus cos of latitude A into cos of latitude B into sine of longitude of A minus longitude of B divided by 2 and the square of it. Now, this will help you if you are into that industry, because today at Google Maps you can actually have this longitudes and latitudes available very accurately. So that is the beauty of technology, that you go to the Google Maps, you can figure out the longitude and longitude latitudes also, and then you can have a DAB. Now again, um, we need to understand that DAB is just, it's a kind of simulation which says overall distance will be like this, right? And based on that, there is a factor of 1.3 which needs to be multiplied. So after determine this, if I multiply it by 1.3, it will give me a typical road distance to manage my mileage estimate. So if I say that, okay, I am going from point A to point B, figure it out what is GAB multiplied with by 1.3, that give you a typical distance which your truck will be covering, right? When it says will be covering means in terms of mileage. And now if somebody is claiming that your mileage is 18 kilometers a liter, multiply this with over there, you will be able to figure it out what exactly we are talking about, right? So if I am saying that I will use, I will use 1 liter to cover 18 kilometers, then I will take 1.3 into DAB to cover that many liters for that very distance itself. So that's a very scientific way of doing the mileage estimation. It also helps you understand that what is the actual amount of fuel you are consuming over there. Now, I will say if you have an access to the data, right, with your organization, try to do this formula, right, and see, right, maybe this may vary, this value of 1.3 may vary, but you should be able to figure it out, that based on this formula, and if this is my total fuel consumption bill, right, then figure it out what deviation we are talking about. It is 1.3, 1.4 to 2.3, and if it is really high, then it means that either your truck need maintenance or there is something wrong going over there, or you actually need to a root cause analysis over there, right? So but generally this works. Other issues, future demand. So we don't know what is my future demand. Very important thing, demand forecast. Facility cost, right? So one is your fixed cost, so not proportional to the amount of material that flows to the warehouses. So that's a cost which will always happen whether you have it or not. For example, whether you have stock or not, you have to pay your employees, fixed cost, right? Handling cost, which is your labor cost. So you will not have a permanent labor. So if your trucks are coming, you get a labor, they will charge you a few hundred rupees. They will unload the stuff, or they will load the stuff back in the truck. Utility cost. So when I say utility cost, it is about electricity, water, all those things, maintenance part of it. Storage cost. This is typically proportional to the inventory level, right? So if you are maintaining a thousand units of inventory, the maintenance is accordingly. If you are just maintaining nothing, then you practically don't have to maintain anything in terms of storage apart from the fixed cost, which is typical rent or the cost of owning ship. And the facilities capacity. So not every facility can store everything, right? So The food storage are different, the electronic storage are different. So all those the medical storage are very different over there. For example, I will say why it is so difficult to manage based on the product. um, GE, General Electronics, right? So they have this manufacturing of medicines which are radioactive in nature, typically consumed by cancer patients. Now, with radioactive medicines, the only thing is that they decay, right? Because all these radioactive materials decay over a period of time, and they decay from the time they are, you know, on Earth, right? So the doctor writes a prescription that you need to take this medicine of this potency, right, at this time. So when GE received the order, they have to actually manufacture that tablet in such a way that when you receive that tablet and when you have to eat it at 6 p.m., the radioactive content is exactly same. Anything less or anything high is dangerous. High will can kill you, less will not be effective on your treatment over there. And that's where GE has a very specific programs from the IT sector, from the logistic, where they actually manage this entire supply chain. So you can see how difficult it is to maintain such kind of a supply chain management, and that's where all these things starts creeping in, right? What kind of facility, radioactive facilities, medicines on time you have to go, uh, what are the capabilities, right? And then you have to track it also because the radioactive. You have to be a lot of surveillance goes with the government over there. So we talk about, in supply chain we talked about a lot of many things as of now. One of the thing is storage cost. So what is the inventory turnover ratio? So inventory turnover ratio is typically given by lambda, which means what is my annual sales divided by average inventory level. So if I am selling, let's say, 1,000 pieces of a particular product in a year, and I am maintaining, let's say, 50 is something which I always have in my stock at my warehouse, then 1,000 divided by 50 is what I will call as a lambda, right? So this helps. This is a good ratio to understand total flow through the warehouse to the average inventory level, right? So if the ratio is lambda, then the average inventory level is total flow is lambda itself. So this helps you to understand that how fast your inventory is moving, right? So if you have more than one, which means that you are stocking more than what you are selling, right? If it is low, it is good, right? But extremely low means that you also have places where you have a stock out, right? You are not able to fulfill the orders. So do not fall in the trap of these ratios. They need to be looked with other aspects of supply chain management. But definitely a higher ratio is not something which is appreciable, and extremely low lambda value is also not very appreciable. Now look at this network. Slide 22. Sources, you have plants, vendor ports, then you have all these, supply areas, then you have all these warehouses, field warehouses, and the other customers. So all they are interlinked over there. The question is this easy to manage, right? I have multiple warehouses. So one way, which was couple of years back, and it's a very big trend in India to save tax, is to have warehouses in every state, because every state has its own taxation. So they just want to have more and more warehouses to gain the benefits of tax, uh, and they create lot many warehouses. So is this good? Yes. Is this bad? Yes. How? Let's see. So it's improved service level, right? Because it is good thing due to reduction of average service time to customer, right? So if you have a warehouse in, let's say, in typical every city of a state, you can really fulfill the demands very quickly. So from that perspective is very good, right? It is bad also because then you have to manage a lot of inventory at a lot of warehouses due to larger safety stock, because you're always afraid it should not be out. Now, if you are keeping 10, 10, 10, 10 at every places, you eventually land up to perhaps have 1,000 pieces of inventory which is never been used because you are always rolling it over, which may not be required as such. Bad because increase overhead and setup costs. If you have multiple warehouses, every warehouse has its own set of costing, transportation, employees, everything is there. And change in transportation cost, right? So reduce outbound transportation cost. Outbound means when you are going from warehouse to another place, so that will reduce, right? Because you have many warehouses near to the vicinity, so output transportation is very less. Increased inbound, which means that if I have to send multiple trucks to multiple warehouses, I spend a lot of time, a lot of money also in putting goods in the warehouse, which is the increase inbound transportation cost from the warehouse perspective. So, what is the so this does this mean that we need to have only one warehouse? No. So there is needs to be an optimal way of finding how many warehouses is required, right? So this is typical warehouse location models, and now all these things will be used in your supply chain network modeling, right? So we are still on that topic itself. These are all components are into supply chain network modeling itself. So how many warehouses we are talking about, right? So we need to understand 4 points. One is geographical and infrastructure conditions. So in that state where I want to have a warehouse, is it safe? What is the infrastructure? Are the people available to work over there? Is the labor cheap over there? So those things needs to be considered, right? And again, it's a vis-a-vis requirement, right? So for example, I will say, okay, I will not have a warehouse in Delhi, but I will have something, in the outskirts of Delhi. But it may happen that your labor cost is so expensive over there that moving back inside Delhi is cheaper. So we need to take all these parameters over there, or perhaps consolidating warehouses at times is more costly because of the maintenance or the place where you want to consolidate rather than splitting it up or renting it out. Natural resources and labor availability, local industry and tax regulation, right? So what kind of industry, what kind of customer segmentation I am dealing with, and taxes. So taxes, and in India we just have GST, which is a big step, saying that we will have a uniform tax. So now the warehouses are in a mode of consolidation, because now every tax state will have a defined way of doing it, and there will be no octroi moving from one place to another place. So you really don't want to have multiple warehouses, or you want to reduce the number of warehouses over there. And the public interest, right? You cold storage or all these things are heavy, and um, public interest is also required, right? Whether you want to have that kind of a facility over there, um, because of the social reasons within that locality. So, which means that not every place is beneficial for warehouse. So, you need, based on these parameters, you will figure it out what is the best suited locations for my warehouse, and then you have to further consolidate to figure out how many warehouses. Right? So, a typical network design model will have several products are produced at several plants. Each plant has a known production capacity. There is a known demand for each product at each customer zone. The demand is satisfied by shipping the product via regional distribution center, and there may be an upper bound on total throughput at each distribution center. So these are the typical consideration or the typical components we talk about in a network design model. In a location model, there may be an upper bound on the distance between a distribution center and a market area served by it. A set of potential location sites for the new facilities, right? And the cost to it, setup cost, Transportation cost, which is definitely proportional to the distance, no doubt about it. Storage and handling cost based on the labor, electricity. For example, if you go to in an area which is very remote, you may not have electricity to operate, and then if you start running on gensets, which means that you are consuming, you are spending more to maintain that warehouse. And production and supply cost over there. So, location problems are complex in nature. Um, if you have number of customer increases, products increases, how many locations you're talking about warehouses, and the number of market zones we are trying to supply. So, if they keep increasing, your designing problem keep increasing. So you need to figure out an optimal way over there, and that's where the segmentation, the aggregation, the transportation model, the mileage part, all these things comes into play. So we have this. So we discuss about some fundamentals of the modeling. We discuss about the problems. We discuss about the way theoretically we can solve this. And I always say these are all mathematics behind it. So what is the solution technique? So one is the exact algorithm. So there are certain algorithms which gives you optimal solutions, and one of them is exact algorithms. Other is your heuristic, right? So heuristics are based on your past experience, what has been done in last 10 years, 5 years, 2 years, and based on that you try to determine what will happen in next 1 year or 2 years or 3 years. So these solutions are good because they are based on heuristics. So when I say good, it will never give you a trouble, right? But they may not be an optimal solution. So they not be the the best things, but they are good enough to go with, not the optimal ones. So other one is a simulation model, right? Which is like as a network designer, I key in all the parameters. Okay, from this location to this location, how many warehouses, what kind of a demand I have, what kind of customer I have, what is my mileage index to it, what is my cost of operating a warehouse, what are the labor cost, and then I start simulating, right? When I say simulating, I will say, okay, what if I knock off this warehouse, what will happen to my supply chain network, what SLAs I will fail, where my cost will increase. Okay, let me take another thing, I will increase another warehouse over here. Am I able to have a better thing? So these simulations are done by designers, and there are softwares to it. This is not something which you can do just on the paper or the on normal thing. They are designated software where these designers put and feed in all these variables, and they try to see what is the best one. um, Personally, I'm big fan of heuristics and simulation models, because that's how you can take decisions. Exact algorithm are for optimal solutions, but then they are very rigid also at times, which may not work, and you have to do a lot of customization around it also. So we talk about the optimization technique, which are mathematical in nature, and then we will talk about the simulation, right? So optimization technique deal with static models, right? Averages, mean, variances. So we talk about heuristic over there. We talk about algorithms, and they all deal with the averages over there. But they do not take into account changes over time, right? So over the period of time, the road has widened up. We don't care. The truck technology has improved. That will not help you. They have a political environment which has changed over there. That will not be taken care of. So these are like mathematical models. So it is always 1 plus 1 equal to 2. So those things are not considered in optimization model. Simulation is a very dynamic thing, right? So you can key in every other factor. You can give a value to every other factor you decide. So you can even decide that, okay, if there is a government A, then this is the weightage to it. It is government B, this is the weightage. Government C, this is the weightage. If this is the leader, this is the weightage, and based on that you can actually see how it will happen. For example, if I have a very strong union of transporting industry, I need to factor in terms of retaliation, the risk I am carrying with the unions. So I will simulate it. Or if I know that the new leader is not strong enough, right, then I know that I can have a better way of operating my transport system. So all those things can be taken care in simulation. And again, I have suggest that simulation is a typical designer's work and done by softwares which are very expensive, right? You can build your own software in Excel by use of macros, and you can try to do this. It's a fun exercise, and if you can optimize for your own organization or for your area, fair enough, you can always use that. Now, simulation models allow you for a micro level analysis. Micro is like, going very deep into the system, right? So what is the ordering pattern, right? What kind of orders I am receiving, what quantities I am receiving, from which region I am receiving, in which season I am receiving. So that can be done. Transportation rate structure, right? What kind of mileage, what kind of truck, day, night, all those charges can be factored in. Inventory policies, right? So we discussed about three inventory policies in our first session. So what inventory policy I am into consideration, how I'm calculating my cost of inventory, that can be taken care in simulation, right? Warehouse movement of inventory from warehouse 1 to warehouse 2, which we typically at times, we'll say warehouse to warehouse or plant to plant movement, right? So those things can be taken care in your simulation exercise. An unlimited number of products, plants, warehouse, and customer, right? So there I know I can add n number of products because it's simulation, right? So if you have a strong computer running that software, you can keep increasing these products. So that's where trade promotion management, your APO, supply chain management, all these softwares, transportation management, even management, all these software starts pitching in. Or you can just keep feeding parameters, so you can just keep simulating it over there. So the question is that what is the best thing to do, right? So it seems not optimization, but is there a disadvantage of simulation? Yes, there is. So it fails to support warehouse location decision, right? Because it cannot give you, it will simulate a scenario, but it may not be able to provide you a very great insight from the warehouse location altogether, right? Until unless your simulation model is very extensive, which means that it will be very costly simulation to run, which eventually may not be efficient in terms of the output. So you may say land up paying a few thousand or few lakh of rupees to a designer to simulate all the parameters over there, and eventually you figure it out that the benefit you are getting is just few thousand rupees. So that's a lost stuff to it, right? And that's where it's only limited number of alternatives are considered, because if you start, you can theoretically you can have n number of parameters and number of options to it, but practically that will not be the case, because with every path there will be a charge by the designer. The nature of location decision is that they are taken when only limited information is available on customer demand inventory policies, thus preventing the use of micro level analysis, right? So micro level analysis at times may not be there because you don't have the data. You are moving into a territory which has just developed. Lack of data also hits it. So what is the recommended approach, right? So recommended approach is first use the optimization model to see at the macro level what is happening. So at a high level, figure it out that what should be the my supply chain over there, right? So which will talk about aggregation of customers, which will talk about distance travel to the market. It will talk about your inventory costs using your EOQ model, which we discussed in first session. So these thing will with these thing at a macro level, you are able to figure it out that okay, overall, this plan looks okay, or these are the 3 or 4 plans which looks okay to me, and then use that or try to feed that decision level into the simulation model to decide on the micro level nitty-gritties of your supply chain, right? So again, I said it's a very expensive exercise to do, and there are teams, there are software who keep doing this on day in day out basis, and you have a mathematical model first, and once you decide on that, you feed it into a simulation model and add more complexities within those scenarios at a very micro level to figure it out that what is the best thing to do to design your supply chain model itself. Okay, so I think we are left with another 30 minutes. Let me see how much is there. Okay. Okay, I think we should be able to cover this quickly. Should not be a problem. So information sharing and bullwhip effect in supply chain. We discussed this briefly in our session one, and in session two we will discuss in a more elaborate way, right? I hope. So let's understand what is an information, right? So you have a data, right? Data can be anything, right? You go to a library, thousands of books, right? This is, or understand, if I have, let's say, 1000 different books, I tear each book into pages, and I tear the pages all together, and then I put into a big room over there. What is that? Is that information? No, that is typically raw data for me. If I structure that data in a way which can be understood by the person who is trying to read the data, that becomes information. And that information can be applied into my real life scenarios, that becomes knowledge. So this is the hierarchy of data, and that's what information means. That information is a structured in such a way that it can be accessed, understood, and used by multiple information customer. So information is this. So giving me an Excel sheet doesn't make any information if I'm not able to interpret it, right? So always ensure that when you are sharing the data, it is in a way that somebody else can interpret it also. So that becomes information. So why it is important? Because to provide outstanding customer satisfaction by getting information about order status, delivery schedules, tracking, um, information substitute for inventory when dealing with uncertainty. So if I am not sure, what is my demand, but if I have the information, I can deal with my inventory levels, whether I have to increase my inventory or I have to decrease my inventory, right? And definitely, it gives me the competitive advantage. So if I have more information, of my competitors, if I have more information about my own business, and if I can share this across the supply chain, I can always have a competitive advantage over there. Web-based information sharing redefines the org structure and relationships in supply chain, right? Now in today's world where internet is with everyone, and I think you guys have heard about Alibaba, right? So Alibaba is is a forum where world's biggest um, B2B platform. A lot of suppliers, a lot of vendors, all share information over there. Ariba, another technology platform where you can share information in terms of your procurement strategies. So that defines the entire organization over there, right? It's very aggressive, more transparent, real-time statuses update, and that's help you to give a more control of your supply chain. Thus, it helps you to manage your customers better than ever. So, what is a good information, right? Accurate, right? Is this accurate, right? Or is this just like typical, if you go and try to search something on Google, you will find everything over there, right? So accuracy is very important. Accessible, it should be accessible to me, right? Classified, top secrets, right? Something where if you there are a lot of people who will hide information, right? They will try not to tell you the things, right? They will delay sharing information. That is also a problem. May not be a top secret, but somehow they will not share that information. Up to date, right? So now up to date has two aspects, right? One is it may be up to date as of now, right? May not be up to date of tomorrow, right? So I am preparing a report for my higher management based on the data which I am seeing right now. Now if I have to present it in the morning, right, and something changed overnight, that report, that data is, that information is not up to date. So it is obsolete by the time presenting. So you need to understand what is up to date, and the way it needs to be shared is that we say this is the information as on which date till which time, because then it says that this information what I am sharing with you is true to the facts of so and so date at so and so time. That's a proper way of sharing information across the channel. And today we are dealing with almost real time situations where you just open the app, click on it, and you can just see on the click of two that what is the exact position of your orders, your sales, your supply chain, where are your trucks and everything, just on the fly, which is typical real time. We are talking about real time, so this is always up to date, right? Dashboards, electronic dashboards, where you always have the up to date information. Stock exchanges, for example, in the correct form, right? So, what is the correct form of data? Nobody knows. There is no correct form of data. So I can share you a typical text file which has all the name of my customer, their telephone and contact. I say it is all correct, right? It is not in the correct form because you may not be able to interpret the data as an individual or by feeding into your software, right? Your software is very different. For example, I will tell you very classic stuff. If you go to in India, we will write as 2 dot 0, let's make it 6 and let 0, and if I will say it is rupees, right, then it is, no, my 2 is horrible, sorry, so it is 2.60 rupees, right, because I have a big decimal over here, right. So this decimal is talking about saying that this is 2.60. Now you go to any European person, right, there the dot is not a decimal separator. Dot is actually a thousand separator. So they will perhaps interpret it as 260, not 2.60, but 260. But if you give them a comma over here, they will interpret as 2.60. So that's where the correct form of data becomes very important. So try to figure it out, on Google, that how Germans write decimal notation, and you will be amazed that they use comma as a decimal, not a dot over there. Dot is a thousand separate over there, which will actually help you to understand that why correct format is very important in your day-to-day sharing. And this software, SAP, this software is a German software. So if you ever work into SAP software, by default, your all figures will appear as 2,60, saying that it is 2.60, and you start seeing as 260 as 260 over there. So be very particular about these notations. You can always change the sorting, but default setting is very different. Cost and benefits of information sharing. Marginal value of information, right? So that's another topic. Loss of confidentiality. So yes, if you are sharing the information, there is always a fear that you can share it outside, you can whistleblow it, or you can do insider trading, whatever the things. Unethical use by both the buyers and the suppliers, right? So if I know your final conditions, and I can bargain with other people, all those things. So unethical use can be there for this. So there's always, but then again, in today's world, a lot of norms are there, what you can do, but still people do this, and that is also a challenge, that why people will not share information with you, or why you will not share the information with others. When should the information be shared, right? So most companies share a lot of information with supply chain partners during the middle of product life cycle, right? So when the product is not launched, when the product is at the peak of its market, they share the information, right? Because there is no risk. That's a good time. So when you are starting, you will not share, because you don't know, somebody else can uh, sneak in and make more money. For example, Microsoft did it for Apple, right? And during the middle of the product life cycle, and then towards the end, right, you really want information that whether I'm closing it down or not. You just keep reducing the inventory and try to figure it out other ways. um, Sharing can give a greater impact at the beginning and end of the product life cycle, right? So definitely competitors can take advantage of it. um, in the beginning, it may help product development and launching strategy, but so it has a flip side also, which we discussed. And it help may avoiding large obsolete inventory in the chain, and also to plan reverse logistic and recycling issues. Now this is again a trap, right? Sometimes the moment you say I am going out, they stop buying it, so you have another issue with stock piling up. So sometimes company hide this until they are at a level where they can recycle the products, or their losses are all covered. They will just keep selling things. Yes, yes, there is a high demand, and we will produce more, we will produce more. For example, cars, right? So generally when cars are going uh, out of their life and saying that we will don't want make more, companies knows this decision almost 2 to 3 years early, but they never dissipate this market. They just tell it just 2 or 3 months, because they have to clear a lot of inventory which they have built over the period of time, and they want to ensure that they are able to sell their products, and towards the end they start giving discounts, and then finally dealer knows that this is not going to come because you don't have colors, you don't have variants available, because it's going out of the market. Barriers and enablers for information relationships. It is a barrier and it's an enabler also. People, same concept. Power, right? What kind of power I have? Trust, very important thing, to build our trust, and you always have a trust deficit, right? No matter what you do, you always have a trust deficit. Security and risk, which comes of it. Lack of standards. There is no defined standards, where every file which you are receiving needs to be a specific format or not. That is also a barrier of it. Inaccurate information, that is also where people give you a hazy information or wrong numbers over there. That becomes inaccurate information over there. I will also say that if it is not up to date, you are looking for a data for 1st of January, and somebody is giving you a 1st of December data, that is also is as good as inaccurate for you. Marginal levers to promote information sharing, aligning goals and incentives, very important. So from the in the entire value chain, in the entire supply chain, the overall goals and the incentives needs to be aligned. Nobody should be feel that they have been cheated, otherwise they will not share the information. In the first day we have this exercise that what is the optimal price we will have. So somebody will say 4, somebody say 4.8, all because nobody is sharing the information. The moment you try to share the information across all the parties, that give you a optimal part where nobody is compromising on the revenue side of it. Profits are distributed, but still nobody is even compromising on the profit from what they have initially planned. So designing pricing strategies to stabilize orders, very important. At what kind of price we want to, a very expensive item may not be sold, and at times a very cheap article, people say it is of poor quality, that's the reason it is cheap, or early promotions or late promotions also needs to be decided. And again, building strategic partnership and trust, right? So if you have these things, you will promote more information sharing. And I strongly believe, personally, that if you want to do a good supply chain management, ensure that you have a very good stakeholder management, which means that you know who are all the stakeholders in which level in your entire value supply chain. Talk to them, share the information, and be always very transparent and truthful over there, so that you also they also understand your aspect and provide. It still may fail, right? But generally, if I believe that if you are into a role where you are managing stakeholders, you are taking these key decisions, keep everybody informed, and they will definitely keep you informed, because they then understand that it is in their benefit. Aligning goals and incentives. Each participant has an incentive to do the things that will maximize total supply chain profit. It's a typical how to price my product problem, across functions, and pricing for coordination, so that the value chain is maintained. And alter sales force incentive from sell in to sell through, right? So this is, think about this last statement, right? So what is meant by sell in and what is meant by sell through? I will like to hear on this very topic next time, in my third session, which is also the last session. I would like to know what you have understood by this. This is a very important thing, and if you are able to understand this, it will be good for you when you are building that trust on when you go into a different managerial role. So go through it. I will give you as a kind of a task that, see what is sell and sell through, and we will discuss this. Building strategy, partnership, and trust in a supply chain. Again, the same thing. Trust-based relationship, cooperation, and trust work, because again they are all interrelated. Yes, Manpreet, you are very close, right? But again, I will say, think a lot more, right? And try to decode this primary sales and secondary sales, right? So that's where the real challenge is. Try to decode this primary sales and secondary sales. You will be having much more clarity of thoughts on it. So let's discuss this, in the next class. Go through it. A lot of data available on Google, on a lot of universities as white papers. Go through it. It is very interesting topic, and it's not easy to transition over here, because it's a mindset problem. It's not about you don't want to do this or you can do this. It's actually the mindset. That's where all these things come. Trust, your strategy things, your value based stuff, and your cooperation, your truthness. So all the things which we have discussed, in the last couple of slides, everything starts pouring into when you start going into this. That's a mind shift change. Not happens very easily. Just think over it. So designing pricing strategy, that was one of the topics which was in the previous slide. So how to do this? So encourage retailers to order in smaller lots and reduce forward buying, right? So that helps to maintain lower inventory at order levels, moving from lot side based to volume based quantity discounts, right? So instead of lot, just do from the volume perspective. So that is also a helpful strategy to do so. Stabilizing pricing, right? So Walmart, I think you all know Walmart. They have a very concept of everyday low pricing. So there was a strategy that if you, and even today, if in a Walmart store, if you can prove that this product is, you can find on this very day at a lower price, they give it to you free. So for not all the products, but they always say that today this is on EDLP. So today this price you will not be able to get anywhere else. But then this is a very complex thing, right? Because every day you are changing the price. So do not do that kind of a promotion kind of a stuff if you want to stabilize your pricing and make your supply chain more rigorous. Walmart has a huge network of warehouses over there. Limit quantity purchase during a promotion, right? So if you look, they will say a customer can only buy 2 or 3 cans of it. It should not like, first of all I buy 100 cans of it, get another 100 cans for free, and then I, in my own shop, I am selling at 50% discount all the things, so making more money over there. And try promotions to sell through rather than amount purchased, another concept to it. So pricing plays a big deal over here. And strategic partnership and trust. Uh, so if you have trust, everything becomes easy. So easier than said, than said, because building trust is a very long exercise. It's a very long, painful exercise, and once built, it's very difficult even to maintain it. Because once you lose the trust, it's very difficult to rebuild it again, almost impossible to rebuild it again. So it's a very painful exercise to build, and then it's extremely painful to keep maintaining it. So I think we have discussed this whip effect, right? So what management guessed is this, and what they want is this, right? So based on the customer demand, they want to have a very streamlined production plan, but eventually they get this kind of a production plan, and this distortion of demand is known as bullwhip effect. And this is actually observed in Procter and Gamble. So Procter and Gamble has this problem that they try to keep building a lot of products, and with all those different softwares, the kind of information they are sharing, they are never able to figure it out that what is my optimal production plan. And that's where I was telling you in the last class that at one point in time P&G has these RFID in their product. So as soon as they start billing it, it is the information start being sent from all the way to warehouse to the production, so that they can reduce this bullwhip effect. So that started from P&G, and today a lot of things which has happened as innovation in supply chain management are coming from those early days. So what is the effect of bullwhip effect? Inefficient production, right? You are not using your factory or productions at optimized level. Excessive inventory we are talking about. You are either building very low or you are very building high inventory at time, right? And if you are always exceeding your demand at times, then you need to have warehouses, big warehouses, to store that inventory over there. And then high transportation costs. I'm still transporting when it is not required, so all those things start coming in. And poor customer service due to stock outs. So when there is a demand, you don't have a stock. When there is no demand, you have stocks. So which means what? That you always have an unhappy customer, you have a higher inventory, you have a poor production plan, and you have a high transportation cost. So not a good thing to do. And that's where supply chain management comes into play, with all the information sharing and streamlining all those graphs to as linear as possible, as good as your customer demand. So these are some graphs after removing promotions. So this is like point of sales data origin. So this is how your production and everything is going over here. But the moment you do you remove promotions over here, you will find that it is pretty much streamlined. So which means that all those gimmicks of discounts and everything, if they are not strategically placed, then it takes a lot on you, and that's where the entire strategy changes for the product. So causes the bullwhip effect, order synchronization, we talked about it, order batching, uh, trade promotions and forward buying. So you are buying for anticipation, or you are giving more trade promotions, right? One of the bullwhip effect was, Pepsi did it, I think, in somewhere in a couple of years back, that they was so amused that they have assumed that India is going to win cricket World Cup, and they come up with this Pepsi Gold, and India actually not even in the semi-finals that year, and the entire stock was like killed because it's like gold Pepsi and gold color, and nobody was like actually taking it. So that was a big loss over there. And after that, they never come up with the strategy of World Cup stuff over there. So that's another scenario where forward buying and kind of promotions you want to inbuild without having measuring your risk comes in. And that Pepsi is not even of a black color, so you can just still sell it. It is the typical golden color Pepsi. um, Reactive and order reactive ordering, that is also very important, because if I am just okay, today I am selling 10 pieces, let me order 10 more. I don't know whether they are the only 10 customer who are supposed to buy. So that is very one aspect of creating bullwhip effect. And shortage gaming, right? So under capacity, supplier may over order expecting to only receive a promotion of the ordered quantity. So sometimes people try to this create unnecessary shortage. I will say hoardings, uh, create impact that there is a big demand, or sometimes I just want to get more and more, and I just which creates a shortage at the production level, but not at the retailer level. So these things are happening. One of your case study which you need to submit as an assignment is based on the bullwhip effect, the SPA Barilla case study. So please go through this bullwhip effect in detail over there. This will help you in analyzing the your case study. Strategy to combat bullwhip effect: information sharing, collaborative planning, forecasting, replenishments, smoothen the flow of products, eliminate incentives, and vendor management inventory, right? So vendor management inventory is that the vendor manages your inventory. So vendor tells you that what inventory I need to have. So it's a very nice concept used by large companies, and it has been very successful, right? And stocking decisions are not governed by the producer of the product. It is governed by the consumer or the retailer of the product, right? For example, Walmart is not a producer, it is a consumer or a retailer of Procter and Gamble. So Procter and Gamble's warehouse inventory level are actually managed by Walmart. So Walmart says that based on my sales data, I will say you produce another 1,000 uh, um, packets of 100 grams of Ariel or whatever the washing powder you want to. So these are the strategies to combat the bullwhip effect. And the managerial insights which comes with it is that it still exists. It is not something which has been eliminated, or this cannot be eliminated at any point in time, for a couple of things. First, it is a forecast. Based on forecast, it cannot never be accurate, uh, and it really depends on lot many factors which you may not have considered, and those parameters will change over a period of time. Increase in variability is an increasing function of the lead time, right? So more the lead time, more the variability. The more complicated are demand models, right? So the more complications I create over there in the forecasting techniques, the greater the increase, right? So there is a very nice principle which you might all have heard, is the KISS principle, right? KISS, keep it simple and straight. So which means that do not try. That's what I said in the beginning, right? Never try to do German engineering in every other thing, right? So do not try to complicate things all the way. See what is best suited to you, right? It's not something where how good you are in doing something. It is actually how early and how effectively the outcome, how effective is your model, rather than making it extremely complex and then keep reaching out of the data, come up with a model which may be a dead model altogether. Centralized demand information, which is very important. So instead of having a demand at a sector level or a location level, try to centralize it so that your overall production plan can then be defined easily over there. So that is very important. So this helps with the managers, so managers can manage how this can be managed. One of the example is Banneton, right? So we all know that Banneton is a big brand. In 1975, they have 200 stores across Italy, which is a pretty big number, given in 1975, right? I was not even born when this was happening. Uh, 10 years later, the company expanded to US and Japan and Europe. And in 1991, the sale is 2 trillion. It's an amazing figure from Banneton as a brand altogether. Now, how this has been done in those years, right? It's all because of information technology, right? They have a very effective strategy, which they known as quick response. You can do a Google on it, right? In which manufacturing, warehousing, sales, letters are all linked together. So way back, right, in 1991, way back in India, the computer comes in 1986, right? We don't have a floppy drives towards 90s, late 90s, right? So in that era, they have this information available across the channels, right? A direct link between Banneton's mainframe computer in Italy, and that's how the entire simulation model works out of it to figure it out what is the optimal production plan. So using the strategy, Banneton is capable of shipping a new order in only 4 weeks, several weeks earlier than most of its competitors. That's an advantage you get from information technology, and that is the beauty of supply chain management, which is nothing but integrating all the aspects of logistics from the value perspective. So if you are working in those organizations, always understand that sharing information is important. But yes, you need to respect the boundary of what information can be shared, who is receiving end of the information, and try to simulate these models your day-to-day work. You will figure it out that a lot of efficiencies can be gained. And trust, with all these, you always need to build a human aspect into supply chain management, because at the end of the day, the person who is manufacturing and the person who is receiving, they are human. So always keep in that aspect in when you are doing this simulation or when you are dealing in your supply chain network. How does Banneton cope with Bulwe effect? I think integrated information system, right? And coordinated planning, right? Frequent reviews, fast reactions, integrated distribution strategy. So this is the Bulwe effect. I think we are short of time today. Uh, so we are left with supply chain performance management, which is not a big topic. I think we can cover this topic in our next session. And I hope if you have any other query, do let me know. Right, I will be happy to answer this. And have a good uh, evening on your Sunday, and see you next week. Thank you very much. Bye bye.